Good morning, students. So, in this semester for BCA third semester, I am handling a subject called as discrete mathematical structures. So, the first chapter in this syllabus is fundamentals of principles of counting. That is fundamental principles of counting. So, first of all, what do you mean by counting here? Right? First of all, what do you mean by counting? So, counting is the number of way the combination or an event occurs. Right? The fundamental counting principle is a mathematical rule that allows you to find number of ways that a combination can occur. Right? For example, if the first event can occur in 4 ways. For example, the first event can occur in 4 ways, whereas the second event can occur in 3 ways, whereas third event can occur in 5 ways. Fine. Then you can find the number of ways or the number of ways this combination is going to work. So that is 4 into 3 into 5. Total is how much? That is 60 unique combinations. That's why the fundamental principle of counting tells you about what? It tells you about number of ways a combination, number of ways a combination is going to have a combination of events is going to happen. This is a fundamental principle of counting. So imagine that you have a neck or a necktie or a tie manufacturing company. So you can make a unique tie off by changing its colors. For example, you have totally 5 color ties. I mean to say red color tie, then you have green, blue, and then you have white, then grey. So these are 5 color types of ties you have, and you have 5 options to make these ties, and in terms of color, 5 options in color and 3 options in, I mean to say, shape. So 5 colors you can have and 3 shapes you can have. So totally how many unique ties you can make? How many unique ties you can make? That is 5 star 3s. So 15 unique tie you can make. This is one example of fundamental principle of counting. Right? So there are 2 types in fundamental principle of counting. There are 2 types. Let me write this. Number 1, rule of sum, and second one is rule of product. So first of all, we will deal with what is rule of sum. So if you take a task, or let us take if a task, let me take a task is performed. The task is performed in n ways. That is first task I am telling. Whereas the second task is performed in n ways. To say, once again I will continue. First task is performed in m ways, whereas second task is performed in n ways. Fine. Then condition is both the task cannot be performed simultaneously. Both the tasks cannot be performed simultaneously. Then what happens? Then performing either task can be accomplished in one of that is m plus n ways. This is what the basic fundamental principles of counting, out of which that is rule of sum. In the rule of sum, what we do here, for example, it is the first task is performed in m ways, whereas the second task is performed in n ways. So the condition is that both the tasks, that is first and second task, cannot be performed simultaneously. Then the performing either task can be accomplished in one of the m plus n ways. Let us take an example for this one to understand it very clearly. So what is an example? So example, a college library has 40 books in marketing. And it has 50 books in computer science. College library has 40 books in marketing and 50 books in computer science. By the rule of sum, a student can select, by the rule of sum, a student can select among 40 plus 50, that is 90 books. I mean to say, a student can select student can select 40 plus 50, that is 90 books, in order to gain his knowledge in both the subject. In order to gain his knowledge, gain his knowledge in both subjects. This is one best example. Once again, I will repeat the example. That is, a college library has 40 books in marketing, 50 books in computer science. So, a student can select 40 plus 50, that is total 90 books, to gain his knowledge in 2 subjects. This is one of the examples of rule of sum. Okay. The next part is extension of this sum rule. How the sum rules can be extended. So let us start. If a task zoom. If a task T1, T2, T3 up to Tm can be done in N1, N2, N3, M ways respectively. Fine. I mean to say T1 task can be done in N1 ways, T2 can be done in N2, T3 can be done in N3, and so on. Tm can be done in Nm ways respectively. Fine. And condition is no two tasks can be performed simultaneously at the same time. Fine. So then the number of ways to do one of these tasks is N1 plus N2 plus N3 plus Nm. So let me give an example for this one. So example is the best way to understand the rules. So if a student can choose, project. A student can choose project 20 from mathematics and or 35 from computer science or 15 from engineering. Fine. These are the students can choose the projects. Either you can choose 20 projects from mathematics, 35 projects from the computer science, and 15 from the engineering. But he cannot choose 2 projects at a time or 3 projects at a time. Then the number of ways to do these tasks, or what is an option available to the student to choose the project, that is 20 plus 35 plus 15, that is 70 different projects. Out of 70 he can choose any one project at a time because the condition. Fine. So this is an example of extension of some rule.